Welcome everybody to today's webinar for this month's topic, which is a calculated approach to OT cybersecurity risk. So today we're going to go over risk and threats. We're going to talk a little bit about threat modeling. We're going to talk about some threat model examples, risk calculation, kind of using a case study that we have. With you today, or speaking today, is my amazing, outstanding boss, Ryan Zahn, and then myself, Zachary Woltjer. So I've spent 10.5 years in the Air Force doing all sorts of fun stuff. And then 2 years ago, Ryan decided that I might be pretty good at this job, so he pulled me in, made me a cyber data analyst, where now I work on the customer success team, problem solving, helping our customers work on all of their different problems, kind of helping things work smoothly, and then analyzing the data, obviously, which is always fun.
And I'm Ryan. My background is in SCADA, so I used to work at a power utility doing SCADA transmission substation engineering. And then somehow got into the world of cyber about 11 or 12 years ago. So I've been around Verve for quite a bit of time and now part of Rockwell, which we're excited about, all the opportunities we have. And just to kind of pile on what Zach was saying about what customer success is, you can think of it as technical adoption. So we help our customers put the data to work for them. Essentially, it's kind of a blanket statement for that. So one of those key areas is what Zach had put together today and graciously invited me to come along and talk about it with him, which is really about risk, right? And using the data to really prioritize the issues and develop mitigation strategies around those issues. All right, you want me to take him this time, bud?
Yeah, I'll let you have it this time.
All right. So just kind of getting a few of the some of the terminology we use when we talk about risk. And I know many people, I'm assuming, know what these are, but there are some nuances and details of them that are commonly overlooked. So the first is threat. So a threat is the potential risk for a device or a network's security. So it doesn't necessarily have to be individual devices. It can be a grouping of assets, whether they're all on the same network or multiple assets as a system, right? So trying to group things together in a methodology to help determine threats. Excuse me. And then vulnerabilities. So a lot of times when we hear the word vulnerability, we think CVE, right? We think, oh, somebody released a new CVE or this new exploit or this malicious intent. So that is true, right? That is a vulnerability, but another way to look at vulnerability is the weakness in a network or assets design, right? It's not necessarily have to be related to a patch or a firmware issue. It could just be the way that the device was implemented in your environment that is causing a weakness or a vulnerability of some type. So again, it's not just a firmware or software-based thing. It could be configuration or implementation issues as well, where there isn't really a database for you to go to look those up, right? Those are things that you have to discover on your own. The other two items we'll talk about is likelihood and impact. So likelihood is the probability of a threat exploiting a vulnerability in your network or your assets. For example, we talk about different layers or levels of assets, right? We have everything in OT from PLCs to VFDs to relays, network equipment, and then we also have, Windows workstations and servers. Well, when you start looking at likelihood from, that methodology or that context, a lot of people will harp on, hey, we have these controllers that have these very critical vulnerabilities. However, if your network is designed properly, or at least you've done some methodology of segmentation, the likelihood is very low that an attack will occur directly to a PLC or controller. Now, obviously, your results may vary depending on your environment. We've been in several large flat network factories and things like that where, everything is high impact and high likelihood. But in one of the best things you can do is really work at segmentation and trying to limit the likelihood of an event occurring. The other is impact. So A lot of times here at Verve, we use our software and work with our customers to help determine the impact that an asset has. And this can be anything from the impact to, the environment it's in or the network or even the process, right? So if you're running a power generation facility, the impact to generation of power and revenue loss is one of the items that we look at. But a lot of the areas that get overlooked are things like loss of life, right? So one of the things we always are key on in OT and operations facilities is safety. And so, risk and cyber threats have a direct relation sometimes to actual physical equipment that could potentially cause loss of life if misused. And also loss of equipment and resources, right? So just being down, having downtime, loss, losing that, having to replace very expensive equipment, et cetera. So these are all, again, key areas of risk is looking at things like likelihood and impact. So a couple of metrics, and I heard Zach refer to these earlier as the 3 R's in risk. So risk tolerance, and response. So again, just kind of earlier, we looked at what the overall definition of risk was. Again, the potential for or loss expressed in some type of probability that a threat or exploit will occur. And there's a couple of examples, and obviously a risk score is very business unit dependent, right? Zach can probably tell you, and I can tell you that we go to a lot of customers and they all have a different idea of what risk is. But really, it's the ability for you to at least define something with some quantitative value, right? So we want to be able to say that here's our risk. We're sticking to this algorithm. This is what we're going to do. But a couple of examples of those would be to take into account threat and vulnerability, or likelihood and impact, or even all of them, right? So it can be as simple or as advanced as you'd like it to be. Now, risk tolerance is another topic, and this is the one that a lot of organizations have trouble agreeing on. Now, one thing that is pretty much de facto standard is that you will never get to a 0% risk. It's just impossible. And so at some point, there has to be a time when an organization or a business unit will have to determine how much risk they can tolerate before they need to do some type of response or mitigation strategy. And then finally, that leads us to response. So what is the outcome of doing this risk exercise? How are we going to respond to these risks that we have discovered using Verve or other tools out in these environments? Building those mitigation strategies, determining what assets they are, what needs to be done, and what is the best course of action. And a lot of times we also want to say what's the best bang for your buck kind of situation, right? So we also want to seek out the simplest type of responses first to really get us that large headway into the low hanging fruit. Is
All
this
right.
you? Go ahead.
Yep. I think this is where I start.
We traded it up last time.
Yeah. So, so understanding the housekeeping, the key terminology and stuff, now you need to kind of understand why. So threat modeling provides a structured approach to help organizations identify and mitigate risks. All of that is to say, to Ryan's point, we want to protect jobs. We want to protect life. We want to keep our businesses in operation. We want to keep that revenue coming in. We need to keep going. That's why. You need to be able to understand, and you need to be able to protect those assets to continue to allow those operations to be going, to protect your job, to protect the company, and to protect lives. So really, you should be building out a risk metric from the inception of your business. From the moment that first brick is laid, you should be thinking about risk metrics. You should be thinking about how do we quantify these. But realistically, it turns into as soon as possible. Everybody, it's a little bit different. It's just important that you kind of get on that horse as soon as possible to start to get those numbers so that you can start understanding where is our crown jewels, where is our most critical assets that you can go ahead and protect them. Really foot stomping that this is an ongoing effort. It's not a one and done kind of thing. Like we said earlier this morning, it is it's something that you got to continuously build on. And as we kind of explore the topics today, you'll see that more and more. It's a continuous cycle. The moment that you finish the cycle, you're going to be going again, because there's always going to be new vulnerabilities. There's always going to be new threats. There's going to be new assets in your environment, new people in your environment. so many different things at play that it's a constantly evolving process. And then later on, Ryan is going to cover some of the model examples like Stride, Trike, NIST RMF, and OWASP, and Pasta, which is a great name for a risk.
Sounds delicious.
It does sound delicious. There's a lot of different ways to create a modeling concept or a modeling process. I tried to select something that is something that we can all kind of understand and agree on for the most part. It's what I used for the case study that we'll be talking about later. It's a 9-step process that kind of helps you to evaluate and to fix the problems that you're seeing. So first and foremost, you need to identify your assets. You want to know what's actually in your environment. Second, you want to do your threat identification. So depending upon what kind of business you are can impact the sort of threats that are coming after you. But for the most part, there's going to be a lot of similar threats no matter what business you're in. Just being a business is going to have, you're going to have a threat from somebody. So vulnerability assessment, so this kind of builds off of really the identifying assets. Now that you know your assets, you can identify the vulnerabilities, both within the network infrastructure, the way that it's built, as well as the devices themselves. And then again, building off of the vulnerability, you can assess the likelihood. So what is the likelihood that these vulnerabilities are going to be exploited? So you can, start looking at them and saying, okay, this is a critical vulnerability, but there's a very slight likelihood that it's ever going to be impacted, which could then push it further down the list as far as prioritization. And then finally, for this page is impact analysis. So understanding what each of these assets are and what the impact is on your business operations is vital. Kind of like Ryan said, in some of these, in some of the operations areas and in some of the floors, every single asset is important. Every single asset is important for business continuity, but you got to pick your favorite child. You got to look at it. You got to look at, okay, what can we absolutely not live without? What keeps our business not just running, but thriving? And so for the next page, so risk calculation. So I like to use the likelihood times impact model for risk or for calculating risk. So this is kind of that where that math comes into play of now we understand what the impact and the vulnerabilities are. Now let's start looking at it and saying, okay, what's the actual risk associated with each of these devices? And once you have that, you can move on to step number 7, which is prioritization. So you want to start with the most catastrophic, the most critical devices, and the most at-risk devices, so that you can start putting kind of your money there to start protecting what's most important to your business. And then, perfect segue. So step 8, mitigation strategy development. Now that you know what the problems are, you know where the risk is, you can start fixing them. And this sort of strategy is really where you're going to start turning, okay, how many birds can I kill with as least stones as possible? And then finally, step 9, risk monitoring and review. So again, this is a continuous process. So it's just continuing to monitor, continuing to review, and continuing to get better. So now I'm going to start diving into each of these items a little bit more thoroughly. So first, you need to identify what's protected. So whether it's hardware on the floor like PLCs, servers themselves, whether it's safety mechanisms, whether it's AC drives, engines, you name it, this is kind of the hardware that you need to understand. Next is software. So a lot of vulnerabilities come from software, especially when you have some wild software on workstations. We've kind of seen it all. Understanding what software is actually in your environment so that you can start to mitigate the risk associated with each of those software items. So data, this is kind of, data is the lifeblood of business. So being able to understand what data is where and kind of how it interacts with itself or interacts in the network, I guess. This can be very, very critical in terms of how do we segment a network out? How do we make it so that not anybody can walk into this place and shut down half of these stations?
Right. Yeah, that's one of the more commonly overlooked items as well when it comes into doing a model and risk analysis is that you really have to take into account not only the hardware and software, but also data that you have stored that is detrimental if it were to be in the wrong hands. And some examples that are very basic that come into play is exactly what you said, which is like network drawings, network architecture data, as well as even things like backups, right? Storing backups into a particular file store somewhere. That is considered data that is essential to your environment. And so something to always keep in mind is, where else is what we consider an asset that's not a hardware physical device.
Yep. And then processes as well. So processes, I forget what your explanation was earlier for the
But
process.
really just around like what processes do you have in place as part of your overall, vulnerability mitigation, how
Gotcha.
you do your patching, your schedules, those types of things, life cycle information. Those are all, processes related to your assets. And so that is should be considered as part of your assets as well, because it is, information that can be used to glean some malicious intent from finding all where your dead bodies are, right? So it's, yeah, you gotta,
Everything.
yep.
So threat identification, as I mentioned before, a lot of it is going to be specific to what business you're in. So if you're in manufacturing, you may not have to worry so much about threat actor or not threat actors, but nation states. Whereas if you're, say critical infrastructure, you're a power company, you're probably going to want to worry more about state actors than another manufacturing company. So there is other areas as well. So these are kind of the key 5 ones. So hackers, which can be broken into all of your different groups, like script kiddies who are just trying to get out on the web and prove how awesome they are. Malicious insiders is one that's often forgotten about, simply because you're going to have employees that could come back with malicious intent, and they understand these processes. They understand how to get into these networks, and they can really be the ones that cause the most damage. State
It's funny
actors,
enough too, like it doesn't even have to be purposely malicious, right? It
true.
could be, somebody not realizing that they're just running around with a USB stick and plugging it into things, right? That is a threat that somebody is like, oh, I wonder what's on this USB drive. Now we hope that training has, really mitigated that as much as possible, but it's always a risk that we have, right? So it could be accidentally malicious employees as well.
It's a bit of a wild card.
Right.
So hacktivists as well. So there's some hacktivists that are simply just trying to shut down manufacturing, depending on what kind of business you're in. What was you had a great example earlier? Was it
It was a power generating company. There is a specific well-known hacktivist club that was upset that they were still using coal. And regardless of where you stand on that, they were attempting to, ask in public with this IT personnel that worked at that facility for, individual secrets or secrets into the internal environment. So it does happen, right? I mean, we don't hear about it a lot, or we're not directly, seeing it all the time. But that's one instance of a colleague or a friend of ours from a customer had told us about this that happened to him, and had to deal with that. So again, got to keep your ears open.
and then finally cyber terrorists, which if you can imagine a cyber terrorist trying to shut down a power company, that's like that's their goal, their entire goal. So yeah, this is just identifying your threats, identifying who's coming after you, and who's most likely going to try to attack your environment. So vulnerabilities, as I said kind of before, once you understand your assets, you can start identifying your vulnerabilities, both in hardware, software, access controls. So big one, like I mentioned earlier, is your admin account still have the admin username, or have you changed the username, or are passwords being changed every 60, 90, 180 days? Misconfigured ACLs, kind of going right back into the access controls. Insecure configurations. This kind of goes back to the processes and really just making sure that things are done correctly. And then
Mhm.
segmented or flat networks. So a lot of OT networks, I think, love kind of having a flat network, and it can be very detrimental because once a hacker gets into one place, they just kind of have free reign after that. So having a properly segmented network to help limit their capabilities. And then finally, gaps and countermeasures. So it's always important to have those countermeasures in place.
Yep. And that's a lot of this, it sounds like security 101, but I mean, we still run into these types of things in OT. And there is some, technical feasibility areas in there where you can't do certain things, et cetera. We understand that. But, I had an example that I mentioned this morning on the AM webinar, which was, I went to a power facility and I had gotten some credentials from them to do some configuration work on an engineering workstation. Well, I happened to about a year or so later go to another facility that happened to have the same type of it was a paper mill at this point, but they had a power generation facility on site. They used the same type of control system, and they didn't know the password, but I did. It was the exact same one that I had used the previous year at a completely different facility from a completely different company. So a lot of this may sound like basic things, but it is still a very, widely seen issue in these environments is that some of the basic things aren't even taken care of. So something to keep in mind.
It's always the little things that hurt you the
It
most.
is, yeah.
So identifying likelihood. So now that you understand your vulnerabilities, you can start kind of establishing the likelihood of what is the what is the likelihood? What is the probability that somebody's going to be able to exploit these vulnerabilities? And there's several different outlays for this. One of the big one that I'll mention later during our case study is the EPSS, which I'll dive into a little bit more. But just understanding what is the actual probability of these vulnerabilities being used against us. Impact analysis, my favorite. So understanding the impact of every single asset is imperative, really, to understanding what the risk is. You want to be able to, you want to understand what the consequences of an attack would be. You kind of want to come into it from that mindset of, okay, somebody is in our system. If they attacked this specific asset, what would the impact be on our business operations? If they just go after a safety module, okay, that might not be too big by itself, but if they go after something that's nearby, they can cause potential loss of life. Or if they shut down a series of PLCs, AC drives, they could shut down an entire manufacturing line or, a power system. So really understanding what is the consequences of an attack so that you can go in, you can understand what the impact is going to be, and then you can quantify that. So you can write it out and say, okay, these are our crown jewels. This is the most central area of our business that we need to protect. And then from there out, you can say, okay, that's the critical, that's the high, medium, low, and kind of emphasize outwards and start putting the proper mitigation processes in so that even if they get in, your most critical devices are the most protected. So risk calculation. So as I said before, I really like the likelihood times impact, but it's also very important to add in the threat information as well. So understanding, okay, what is the likelihood of every vulnerability being exploited, and then multiply it by the impact that it would be if it were manipulated or taken down. So what is the risk of every single device now that you understand those key characteristics of that data? So you can take the information and say, okay, even though these are our crown jewels, we're making sure that these are all low risk devices, that the likelihood of them being attacked is low, so that we can focus on other areas. Risk prioritization. So you've quantified all of your assets, what the likelihood of it is. You understand what the risk of each of these assets is. Now you need to start kind of taking and putting them into an order that makes sense. So you need to understand, okay, these groups of assets right here that are critical, we can go ahead and we can start patching on them, or we can start replacing them if their life cycle is discontinued or end of life. For other devices, we may have to accept risk. We can add additional segments to segment the network out a little bit more. All of these are different areas of understanding. Okay, let's put it all into a list. Let's pick our favorite child. Let's start protecting that area first. So mitigation strategy development. So now that we have a defined list of at-risk devices, we can start the mitigation of, like, kind of like I mentioned before, with the prioritization. You can take these initial ones and you can say, okay, we can go ahead and patch these to fix these to lower the risk even more. We can segment it out. We can create honeypots, access lists, authentication controls, encryption. We can implement a least privilege policy to, limit the capability of malicious insiders, whether purposefully or accidentally. Um, and you can build a strategy out that's going to consistently, hopefully, keep attackers out. So risk monitoring and review. So kind of as I was foot stomping before, this is a constantly ongoing process. So you got to continue to monitor. You got to keep your security posture as well as possible. You got to look for areas of improvement, monitoring for new vulnerabilities, and if new assets are added in, you need to be able to catalog those and kind of start that process over of understanding. Okay, these are the new assets, the vulnerabilities, and then again, what is the risk, what is the impact of these new assets, and kind of adding them to your overall listings, and then reviewing and adjusting. So for some customers we recommend quarterly, for some customers annually. Go through and review your inventory, review your impact, and then improve, consistently and constantly improve.
All right. So I'll go and take these. And then just FYI, I do see the questions coming in. I will get to those here in just a second. Emila, I think we actually will be able to answer one of those here just shortly. And then Don, I'll respond to yours as well here in just a second. So very quickly, one of the examples that we're going to show you here in a second is something we ran through with one of our customers using a model that is well known, like a well-known threat model that's out there. So Zach showed you an example of some of them earlier. I'm going to dig into them here in a little bit more detail. The first one, and specifically why I'm doing this one first, is I will actually show you what the quantitative output looks like from this, and so that we can get an idea of how you can calculate these values with these different types of impacts. So STRIDE is an acronym that stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So most of you probably understand what these terms mean. Spoofing is acting as if you as something that you are not. So trying to spoof, IP addresses, spoofing data, spoofing a service, etc. Tampering, modifying things that should not be modified, or you do not have the ability or shouldn't have the ability to modify, right? So that's kind of a mixture of both vulnerability and configuration problems. So allowing people to tamper with things that shouldn't be, but that is a type of threat. Repudiation is actually a new terminology for me personally in my vocabulary. I didn't understand what it actually meant, but from a security perspective, essentially it's denial of the truth. So there's actually two sides of this coin. It's essentially saying that you did something when you didn't, and then and then saying that you did something when you that you didn't. Sorry, inverse of those two, but essentially related to logging or having some type of audit trail, or essentially a chain of command of how certain events occurred and went down in an environment. So having that ability to look back on information such as logs, right? So having that access, documentation that shows who logged into what and when and how. Information disclosure, very different depending on different types of facilities you're in, but from a general network security type of context, saying, hey, we don't want to, have people getting our network architecture information in the public that could be used maliciously. But on the other side of the coin, if you're a manufacturer of like sauces, for example, right? You don't want people to know your secret sauce recipe, right? Those are other types of things that you want to think about from an information disclosure perspective. Denial of service, I'm sure we've all heard that term before at some point in times in our lives, but just as a review, essentially causing the loss of control of some type of service, program, or process. So using some type of methodology to deny access or the safe running of that particular service or process. And then last but not least, elevation of privilege. So essentially giving users the ability to access or gaining access where they shouldn't be, right? So based on access, authentication and least privilege, those types of things. So essentially essentially from the grand scheme of things, it's looking at each of these areas as a potential threat and then using that information to really determine what your threats are. So the next slide here is actually going to help start answering one of the questions here, which is how do you quantify this? So with this particular customer, and again, we do this with a lot of different customers, just depending on what their what their process is. We don't necessarily recommend the models to them. We kind of help them develop a process, and they have to actually run through the process. Our job, Zach and I, is essentially to be able to take that type of information that they've collected through some type of threat model exercise and get it into our platform, and then quantify it, and then calculate information from that. So just as a quick example, a listing of the different types of inputs that we will essentially sometimes, depending again on the customer, will bring into the environment. So from the stride model, bringing in some value of high, medium, low, if it was a very basic tabletop exercise, all the way down to very specific scenarios that they have come up with from that model. So essentially bringing those in on an individual basis there. The threat likelihood, as Zach had mentioned earlier, being able to do some type of a assessment or analysis internally of what your threats are from a likelihood perspective. So again, looking at things like data flow, network diagrams, access into the environment from individual assets as well. So trying to bring in that likelihood type of information. Now, likelihood can also be calculated within the platform, but there is a stance there of where not everything is something that you can just calculate from information, right? There is going to be some type of human element involved here as well, but essentially bringing that in as an input, either from a hybrid approach of calculation versus manual input, or a mix of both of those. And then the impact analysis data, right? So one of the things that we've always been doing in Verve since its inception is allowing you to rate assets on their impact, right? And it can be in any context, and you can have more than one impact, right? You could have an impact to network, an impact to safety, an impact to the defective products from if this were to go down, are we going to have a quality issue of our output? And so being able to bring that in one or many facets is also important. And then finally, what's the calculations from that input? So we have an overall threat that we get from the stride model, a vulnerability risk. So looking at just vulnerability data in particular, right? So CVEs and what is their overall vulnerability as a weighting to the overall risk score. And one of the things you'll see is it's usually sometimes a very small piece of the pie. But looking at that, and also in paying particular attention to things like known or active exploits, as well as things that are identified as critical exploits, or even CISA documented exploits of particular interest as well. In this particular one, and we're going to show you in the next slide, I promise. In this particular one too, zone impact rating. So this one is very specific to IEC 62443. So if any of you follow that ISA 99, IEC 62443 guidelines, one of the things we wanted to take into account was the zones, right? Zones and conduits that exist within that standard. And so we wanted to say, okay, let's do these calculations by zone, right? So even though we have individual assets that may have their own specific vulnerability profiles and threats, et cetera, there is, there's a method there that says, hey, you're really only as good as your weakest link in that environment. And so we want to kind of look at everything holistically as well as individually, and be able to kind of swap between those two. And the last is countermeasure coverage. And you might hear the terms like compensating controls, countermeasures, mitigations, whatever. It's all really the same thing, but essentially trying to also take into account what do we have in place that is giving us a layer of protection. And it can be very basic, like hardened configurations, or making sure that we've disabled all USB access in the environment, but also integrations into other data sources. So things like backup solutions, right? Do I have backups of my PLCs, of my desktops and workstations, of specifically the critical ones as well? So just in case you did have some type of malicious attack, that you can be back up on your feet from a business continuity perspective in a rather quick time frame. Same thing with anti-malware. Do we have that in place? Are we using application allow lists? Least privilege, so on and so on. So we want to make sure that we also quantify what that countermeasure coverage looks like. So in this next slide here, this is an example just from this particular scenario that I was going through of what a calculation looks like from an output. And again, I will say personally, this one is on the more basic side. So Zach has done some very advanced calculations with our customers, which is what his use case towards the end of this call is going to go through. But in particular, just kind of walking through what you're seeing here. So again, in that risk table at the very top is essentially breaking out all the individual pieces that we use to calculate a risk, at least in this scenario. So for example, all the zones based on the ISA 99, the vulnerability threat in particular. So looking at specifically the CVEs, the ones that have been detected on endpoints, right? And we can see that from I forgot to put it in percentage format, but if you convert those to a percentage, they are very small, right? From a known exploits and critical vulnerabilities perspective, very small piece of the pie when it comes to overall risk. Likelihood, again, this is based on output from a likelihood analysis that was done with the customer, looking at things like connectivity, data flow diagrams, et cetera, and being able to bring some type of quantifiable value. Now, in this case, all we essentially did was they had kind of a rating system on where do we have very simple access, which would be critical, and then we had high and medium, or actually it was critical and high were together, but essentially being able to say, we did an analysis of all this internally with different groups. We brought them all in. We did a tabletop to walk through how things are connected, and went through this and built an output of a 3, 2, or 1 based on what is the likelihood of an attack in that zone. Impact analysis. Again, Zach had talked through the process there, but bringing in a value out of 1 to 3 in this case for how impactful the assets in that zone as a whole are, right? So if any one of those pieces of hardware were to go offline, what is the overall impact to the full process, right? So there is some areas you'd go into where you could probably lose almost the entire environment and it would be fine, right? Your process is still going to run, versus if you lose all of your safety environment, you're probably not running anything anymore, right? Because that's just a bad idea. And then threat. So threat is I kind of broke this out a little bit farther in the stride model output that's down a little bit further, which essentially shows you here's the output per individual asset for what that stride model output is. So looking at things like high risk of tampering and spoofing and repudiation, and going through all those different assets from a grouping perspective, and then averaging and quantifying those or normalizing those into some value from 1 to 3 based on that tabletop exercise. And then finally, countermeasures. And really, in this case, it's actually the inverse. It's lack of countermeasures. So what is the inverse of percent of coverage essentially for that environment? So looking at if it's 100%, there are no coverages in place. And as you go farther down to 0, that's when you have full coverage, right? So again, it's neither here nor there. It could be done either direction, but that's the way I chose to do it in this case because it made sense for some reason at the time. And then after that, we actually are able to calculate a risk value from that. And also there's some other things that get taken into account, but really these are kind of the very specific items or the highlights of that. There's another piece, and you'll actually see this. We actually show a sample risk calculation, what it looks like from a mathematical numerical view, but also looking at weighting, right? Weighting different types of impacts. So and I will tell you this, and Zach will tell you this, every organization that we've worked with has a different idea of what is risk, right? So Don, you asked a question in the Q&A about the risk to like environmental impact and loss of life, and how do you scale all that type of stuff, right? So a lot of that is very specific to each individual customer we work with, because every industry and even each business unit sometimes within an organization will have a different idea of what is their risk profile and what should be used in that calculation. And so that's one of the things that our team, the customer success team here at Verve, or the technical adoption team, works with our customers directly through this process to essentially help guide them on how do you define this, how do you do this, what model should we use, what data should we use, and then start building out a calculation that runs in real time to constantly update you on your potential risks in your environment. Next slide, and so I can give you some more time, Zach, just very quickly. This is a sample of what a stride model output, a more detailed stride model output would look like. So essentially, you're drawing boundaries around different services or zones, et cetera, and looking at how communication, how a user interacts with it, how is there any internet connectivity or inbound, outbound, what protocols are being used, et cetera. So it can be very, some customers are kind of just starting that maturity side of things. So there's that crawl, walk, run type of methodology. And so if you're kind of, and as Zach was saying, this is a circular cycle, right? You don't end this after you do it once. You start once, you look at how your data looks, and you're constantly kind of iterating through that process, whether it be on a monthly or a yearly or every 2 years basis. In some form or fashion, you're going to want to do this on more often because things are going to change. You're going to have new ideas of what risk is. You're going to get, input from your CISO that says, hey, you must start looking at this particular thing that they may know nothing about. And so we want to make sure that we're taking that into account when we start going through risk models. Just a few more very quickly. Trike is another model. This is actually not an acronym. I thought it was from a long time ago, but it actually is kind of a risk-centric type of model that you can use. So defining a system, and this can be broken out more. I wasn't going to waste time going every individual thing, but just kind of getting some information out there for everyone. But defining a system and also building a requirement model, right? So what is our scope? What assets do we really want to take into account? And then we do a risk assessment. So assessment, you can bring in that same process that Zach outlined towards the beginning of the call, that 9-step process as part of this, but also creating, reading, updating, and deleting, right? So you're kind of going through that cycle of understanding and updating that risk assessment on a real-time basis. Data flow diagrams are another piece of information that gets brought into this. And then once you have all this data, you can then start assigning risk values based on that information. Now, obviously, I didn't go into a whole lot of detail. This is kind of just a very brief overview of what Trike is, but I implore anyone that's interested to take a gander at that particular risk model if they're curious. NIST RMF is another one that's been rather standardized. If most of you probably are familiar with NIST, usually has a very wide net and very applicable to multiple types of compliance and regulatory standards as well. Again, you'll notice the circular pattern here. It is a circle, but basically categorizing, selecting your controls, implementing your controls, assessing if your controls are actually successful and working the way you expect. Authorize systems, which means authorizing additional types of inventory and assets to be part of that risk, and then monitoring the controls in real time to determine if we need to make changes to our model, and then constantly iterating through that. Pasta, there's a lot in pasta, but just kind of it's very business oriented, but also from the attacker's perspective is the way pasta is kind of designed. So first of all, internally, you define your business objectives to determine, okay, what is really the outcome of this from a business side of things? What are we trying to protect? What are we trying to do from this? That'll help you define your scope for what assets need to be involved in this, and then start going through the whole process of decomposing the application and analyzing the threats, doing a vulnerability assessment or analysis, and then the attack modeling piece in particular is kind of what I was getting at. Is it's a very attack-oriented type of model to where you're looking at it from the attacker's perspective of what they can do and how they're able to access environments. And then finally, that gives you an output of an impact analysis when you run through this, which we can then feed into a risk model, including the things like the impact, the threat, the likelihood, and that'll give us a risk output. OWASP, I'm not going to go through all 10 of these. This is called the OWASP Top 10. OWASP is very web application specific, right? So not a whole lot of applicability across other types of assets that you may have, whether they be software or hardware. However, if you do have some type of web application that's being used internally as part of your DCS or your OT environment, you could actually use this for those specific scenarios and then feed those through the traditional models like Stride to bring in that additional context that's needed from a software perspective. It's also useful as well if you, by the way, have any internal applications that you've developed for something, right? Is being able to use this to really help outline what that threat looks like for you. I'll probably have you just kind of skip by this one, Zach, for reference of time, but some of you are probably familiar with IEC. But again, I mentioned zones and conduits, so being able to group assets by zone, things that need similar cybersecurity requirements, and then the conduits are really the communications between zones. So understanding how they interact with each other, whether it be services or users or processes that that go from one to the other, being able to really outline that and then use that as part of your threat model, only because it helps simplify the overall risk process, right? Because if you start thinking about doing this on a per asset one-to-one basis, you're never going to get anywhere. You really want to look at it from a system-wide perspective, and then if you need to, drill into individual assets that are of particular importance. We used a weighted scale, by the way. So looking at things like, do we want to rate the impact as a 30% weighting within the overall risk score, the likelihood, countermeasures, vulnerabilities? Again, this is not limited to these individual things. You obviously, from a risk perspective, whether you're using our tool or just doing this as a business, you obviously can have more and more different areas that you want to look into, but in particular, it's worthwhile rating how those different outputs affect your overall risk score. And so really working with the internal groups to understand what that weighting should be. Assigning values, mine was very basic, 1, 2, 3, just for simplicity purposes for this webinar. But then also countermeasure coverage, so looking at those overall values. But then that slide that Zach was just showing here is an example of what a risk score calculation could look like. And this is actually what the one that we were showing you shortly a little while ago in our platform was utilizing. So again, not the most advanced in this case. Zach has some that use all kinds of other values like EPSS scoring from vulnerabilities and threats, which we'll talk about shortly. But being able to quantify my compensating controls, in this case, I was using 4, so over total assets times 4 to normalize that data. Likelihood impact score, so again, inputs from the threat model exercises that we were running through. And then from a vulnerability perspective, putting weights on critical vulnerabilities and known exploits, and then bringing in the threat score. So essentially just kind of showing how that works, but then finally normalizing that risk to determine an actual percentage of scale from 0 to 100 in this case.
Cool. Thank you so much, Ryan. All right, so talking today about a lot of the risk, we wanted to cover a case study. So something that was actually used by one of our customers that we used in actual operation, and it's still in operation today. So in this case study, this was a manufacturing company. And the first thing that we initially did is try to understand the asset inventory. So first thing, Verve is a little bit of a shameless plug here, but we are excellent at asset management and asset inventorying. So we use Verve's Asset Manager to display the environment's assets. So after we initially went in and we started to gain all of their assets and inventory them, we got approximately 15 plus sites with assorted connectivity. Some of them had connectivity to a corporate network. Some of them were very air-gapped, where it was basically just within that environment and were very limited in terms of connectivity. So that's how the sites were. There was multiple manufacturing lines at each of these sites. So of the 15 sites, I want to say there's like 45 different manufacturing lines, maybe a little bit more, somewhere between 45 and 60. And then each site had, give or take, about 2,000 assets at each of the sites. So just for the sake of time and effort, I put 100 OS-based assets, so workstations, servers, laptops, etc. And then 1,900 embedded assets, so everything from PLCs, safety devices, etc. And over on the right, we actually took a screenshot of, within our UI, our reporting UI, the actual asset inventory look. So as I said, this was a manufacturer. So I put a star next to each of the potential threats that would be going after this particular company. So of course, hackers, anybody that's a script kiddie, they just want to prove that they can hack into something. So everybody's a little bit of a threat, or everybody's got a little bit of that threat. Now, if they're successful or not really depends on your level of maturity and defense in depth. Of course, malicious insiders, this is a company, so, full-heartedly expecting that there's going to be some disgruntled employees at some point or another. State actors, so manufacturing, so this was not critical infrastructure. So there's no real reason to say that there's likely state actors that would be targeting this company. So I did not put that. And then hacktivists. So this particular manufacturing company, they deal sometimes with like GMOs and things that are heavily modified in and that can gain some hacktivists, some people that are, sort of like Ryan mentioned before, you're doing coal, so somebody, regardless of where you stand on it, somebody's going to want to be a hacktivist or an activist against this type of stuff. And so we had to worry about that in the case of this threat. And then we did not really have to worry too much about cyber terrorism for this manufacturer. But once we had identified the actual threats, we're able to understand kind of the resources of what is going against you. So next, so vulnerabilities. So again, over on the left, using our Verve reporting tool, we're able to get numbers for this particular environment. So we were able to pull the vulnerabilities for hardware and software, and in the case study, there was about 20,000 vulnerabilities associated with this environment. 2,000 of them being critical, and then around 500 of them were actively exploited in the wild. So those are kind of the key metrics that we usually look for in CS. Not to throw the high, medium, and lows out the window, but you definitely want to save your crown jewels first and foremost. You definitely want to go after the most vulnerable devices first. So identifying likelihood. So in this case study, I used something called the Exploit Prediction Scoring System, or EPSS, which has been around since 2017. First organization developed it. This particular EPSS data feed that was being fed into our VAM instance, it's built and tailored a little bit more for an IT infrastructure. So take these likelihoods with a little bit of grain of salt. But the first organization is trying to build a specific operational technology ICS version so that we can use this in our environment, because there is so many people that are trying to use this sort of data and understand the real likelihood of these vulnerabilities in an OT ICS environment. What EPSS does is it is a percentage assigned to each of the vulnerabilities. So the percentage, anywhere from 0 to 100% chance of what is the probability of that vulnerability being exploited in the next 30 days. So as you can see here over on the right, the graph, just kind of a crude way of showing that data, but it puts all of those into a separate box. So of the 2,000 vulnerabilities, they are cut into 10% groupings from 10, 20, 30, and so on. So you can understand what's the actual likelihood of this being exploited. So a lot of that was pretty automated, which made it a lot easier to kind of feed into the risk metric. So next, that we really started diving into is the impact analysis. So at this case study, the best way that I originally came at this was trying to go from a macro to a micro level. So we started at the site. We essentially we looked at each of the sites. We picked our favorite child, kind of, with each of these sites. You don't have to pick necessarily 1, 2, 3. You can say these two are our number one priorities, something along those lines, to give it some sort of quantitative metric that can say these are our most important sites. And kind of to Don's point, one of the things that is very important is understanding what's at risk when it comes to impact. So the way that I always kind of came across it is, if this were to be attacked, whatever the actual goal is, so in this case, the site, say the entire site is shut down, how would that impact your business operations? Obviously, you always want to say critical, but try to be realistic. Look at things like GDP. How much money is it bringing in? How many employees work there? Things like that. Something that gives it a quantitative substance that you can actually look at it and say, this site is our number one GDP, most employees. It's our crown jewel, period. Let's give it a 10 out of a 1 through 10 metric. So next we look at each of the lines. So depending upon what you're manufacturing or what your infrastructure environment is, You want to look at the lines, you want to look at the systems, and you want to try to quantify them again, kind of in the same area. If this line were to go down, what would be the business operation or business continuity degradation? How bad would it be for our operations if this went down? Once you have those two metrics, something that we try to look at additionally to kind of get it down to the asset level is the asset type. So, it could be a server, it could be a switch, it could be a PLC, AC drive. Kind of look at those as a grand scheme of things. Our AC drives are super critical, so we're going to give them this metric. And this is where things kind of become a very personalized, depending upon where they're used, how they're used in your environment. But giving it, again, each of these three factors an actual number associated with them. And then I listed the fourth thing for outliers. So in this particular case study, there was networking devices that connected multiple manufacturing lines. Those were isolated and outliers. So even though it didn't fall into this automated algorithm, we had to manually go in and assign those specific values to say, yes, it's a networking device. It's not technically part of this line, or it's technically part of both these lines, but it's a 10 because if that traffic were to stop between these two lines, it cuts off half of our operations this site. So now you can throw that into a bigger bucket, if you will. And over on the right, you can kind of see the code that I used to build this impact analysis and to give it a quantitative number associated with it. So now that you have the likelihood, now that you have the risk, you can, likelihood and the impact, you can calculate the risk. So over on the right, we try to take those two, put it into a heat map to actually show these are the critical likelihood, critical impact devices. This is most likely where we're going to want to put our resources in trying to fix, whether it's patches or what have you. What brings us to the risk prioritization. So when you start looking at those high risk devices, you want to look at that and you want to say these are crown jewels. These are where the most mitigations are needed for our business operations. So in the case of this case study, we looked at three important metrics after understanding the risk. One, the highest impact. So what actually has the highest impact in our environment? The highest number of patches. So we want to knock out as many birds as we can with singular stones. If we can take one patch and fix 300 devices, then why not? We need to do that. We need to push that patch. And then finally, the life cycle status. So a lot of these devices are end of life or discontinued. That's important information to look at, especially when you're looking at mitigations and remediation. So what this slide kind of comes down to is now you have these groups of catastrophic, critical, medium, high, low, risk devices. Let's put them all into a list now and then just start grouping them however we can to start fixing them as can be. And kind of all summarizing into the mitigation strategy development. So there's a lot on this slide, but a lot of it comes from an enterprise level. What sort of policies, what sort of patches, what sort of segmentation, what can we do to fix these vulnerabilities so that we can lower the risk of these high impact devices? That's what really this is all about, right? Is trying to fix those devices, try to put the mitigation in. As Ryan said before, you're never going to get zero vulnerabilities in your environment, but what can you do to minimize them and mitigate them? Or in some cases, accept the risk that, we simply don't have the resources right now to fix these outliers or these separate devices or separate vulnerabilities. So we can kind of build that defense in-depth model. And then again, kind of going back to that circle, this is a continuous process. So regularly reviewing, updating your inventory, which within Verve, it automatically does. A little bit of a shameless plug there. But it can automatically see that traffic, and it can automatically see when was the last time that this device was seen by us. And then regularly reviewing the update and updating the impact. So with this case study customer, we still regularly talk about impact, whether it's quarterly or monthly, quarterly or annually. We'll go over impact and say, is this still pretty, is this pretty overall? Are there any new devices, any new outliers that we need to focus on? And then monitoring for vulnerabilities. So again, automatically these vulnerabilities coming from our Verve vulnerability database. so that we can monitor them and try to fix them when needed. Adjusting mitigations. So, do we need to add new firewall rules? Do we need to add new ACLs, access control lists? Do we need patches? What do we need? And then finally, finding areas for constant improvement.